graphing and also finding the intercepts algebraically. So let's talk about graphing this first. I want to find that vertex. Where's our vertex point located? What did you see, Olivia?
Oh,
yeah, but help us out. Where's your vertex?
Oh, here.
So look at your transformations. Where are we going to help us see our vertex?
To +3, or to +3, and then up 4.
Good job. So our vertex will be at 3, 4, and then you're going to use that A value here to help you figure out your next good points, which means we would go where to keep finding our next good points. What do you think, Nathan?
Go down 2.
Good job. Down 2, over 1 in both directions. So down 2, over 1 in both directions, which now plotting all those points, I can see and figure out where my intercepts are. But remember, I want to find those intercepts algebraically moving forward. But you should have used on your classwork, you should have used your graphs to kind of check, like, after you were finding those intercepts algebraically. Like, does that make sense with my graph? That's going to be the same thing on your test. You should check back and forth, right? Like, if you have a graph and you're asked to find the intercepts algebraically, check to make sure they make sense and that they're matching up. That's why we love math, right? You should be able to kind of solve things multiple ways to see that they're matching up and giving you the same solutions. So let's talk about finding those intercepts algebraically. How can I find my x-intercept? How do I find an x-intercept algebraically, Jaden?
Plug in 0 and graph of x.
Great job. 0 is my y value, or f of x, like Jaden said. So I'll have -2 times x minus 3 plus 4. And now I want to isolate the absolute value. So today we're going to do all solving. So if you have a different colored pen or highlighter, highlight that absolute value or like circle it with a different colored pen. And no, this is what I want to isolate. So what would I choose to isolate here? Subtract 4, and then what do we need to do after? Good job. So subtracting 4, so -4 divided by -2 gives us 2 equals the absolute value of x minus 3. And now that I'm here, I can find my two values for my x-intercept. So 1 would just kind of come from as is, right? X minus 3 equals 2, which I know x would equal 5, which is that intercept of 5, 0. Does that check in with my graph? Did I have an x-intercept at 5?
Yep.
Yep, good check. But I have more than one x-intercept, right? Where's my other x-intercept going to come from? When x minus 3 could also be what value? Yeah, if x minus 3 is equal to -2, I can take the absolute value of -2 and it'll turn it positive. So I'm going to end up with having 2 x-intercepts, or 2 solutions here. And knowing I'll find my other one to be at 1. So I'll have x equals 1 and that intercept of 1, 0. And that checks in with my graph. So lastly, I need to find my y-intercept. And how do I find a y-intercept algebraically? Make x 0, so y, or f of x, is going to equal to -2 times the absolute value of 0 minus 3 plus 4. And then just going through with your order of operations, I know I'll have -2 times 0 minus 3 gives us -3. And what's the absolute value of -3? 3. And then we'll have -2 times 3 plus 4, which I know gives us -2. So as ordered pair is 0, -2. So final idea is just to check in for your test. Remember, intercepts are written as ordered pairs, even though you're solving for them algebraically now. Don't get in the habit of just saying like x equals y equals, remember writing them as points. And what other questions do you guys have before we move on? So our last lesson's on solving, and it's really similar to what you did before with solving for your x-intercept. So, good to know. Not a lot of new information today, just a little bit. So when you're solving, think about those steps we took last time in our warm-up. You always, always, always want to have your first goal as isolating the absolute value part of the equation. So that's when that different colored pencil, pen, or highlighter can come into play today. You're going to split your equation into two, a positive and a negative. So remember, your positive just means like as is, drop the absolute value. The negative would mean what you did in your warm-up, right? That x minus 3, also set it equal to a negative 2. Because if I take the absolute value of negative 2, it would turn it positive. You're going to solve those two equations. This is the new part here, everybody. On your mathematical journey so far, if you've been solving an equation, like if you're solving that equation above Nathan's head, and you find x equals 1, what did your teacher always tell you to do to like make sure you were right?
Plug it back in.
Plug it back into check, right? And if I plug it back into check, how would I know x equals 1? What would your check have showed you?
It's the same.
It's the same on both sides. Great. So moving forward in Algebra 2, and once we get to higher level like questions, which is like your first time maybe today, when you're checking, you're not just doing it because you like want to make sure you're right. It's like a good habit to do. You're checking because it's part of the solving process now, because some of your solutions are not going to work. Think about your x-intercepts. We could have up to 2, or we could have 1, or we could have none. So some may not work, and that is what's called an extraneous solution. So if I see the word extraneous, what kind of word do you see within extraneous?
Extra.
Extra. So an extraneous solution kind of means that. It's kind of like an extra solution that's not actually a solution. And we're going to look and see when that is happening in one of our questions. So checking now is not just like for fun to make sure I got it right. It's part of your solution process. But the perk in checking is, yes, it's part of the process, and you get to also know that you're right doing it along the way.
So if it did not, like the answer was not the same, and you're like for sure that you did all the work correct, would you just say extraneous?
Yeah, I'll show you. We'll get to it. So take a moment, jot down example 1, and think about how you'd get started with this problem here.
Are we talking
Yep. So looking at what we have absolute values, we have an equal sign, we have an absolute value equation. What's our number one goal when we have an absolute value equation? Like first priority is to do what? First priority is to always do what?
Isolate.
Isolate what?
The absolute value.
Great job. Isolate the absolute value. So highlight, circle that absolute value, and know that's my first priority. And how would I isolate that absolute value? Ginny, you just helped us out. What would my first step be here?
Subtract 6.
Good job. Subtract 6 on both sides. So I'm going to end up with 2 times the absolute value of x minus 4 is going to equal to 4. And I have one more step to isolate that absolute value, and that would be to do what?
Divide by 2.
Divide by 2. So here's what we have. The absolute value of x minus 4 is equal to 2, and here's where I'm going to check. Do I have that absolute value all by itself? Great. Now that I have it all by itself, this is the point where I can make those two equations. So first one is just as is, drop your absolute value. And when I'm here, what do I know x would equal? If x minus 4 equals 2, x would equal 6. Cool. So now let's solve for my second equation. My second equation would look like x minus 4, but what could x minus 4 also be equal to? negative 2, because if I take the absolute value of it and it's negative 2, it'll turn it positive 2. And now when I have x minus 4 equals negative 2, what would x equal here? 2. And are we done with our problem? No, what do we always need to do? Check. So let's check each of them. And when you're checking, like Jaden said, you're plugging it back in for x. So I'll have 2. Instead of x, I'll have 6 minus 4 plus 6. What do I need that to equal? 10. So let's check to see if our left side is going to equal 10. I'd have 6 minus 4. I know that gives me 2. What's the absolute value of 2? 2. So 2 times 2 is 4. And it's 4 plus 6, 10. Yep. As far as I know, 4 plus 6 is 10. So x equals 6. That's a good check. Now let's also check 2. So 2 times the absolute value of 2 minus 4 plus 6. I need to make sure that also equals 10. Now going through, and my absolute value first. 2 minus 4 would give us negative 2. What's the absolute value of negative 2? 2. So 2 times 2 plus 6. 4 plus 6 also equals 10. So that's a good check. So what do I know? I know I for sure got this problem right. I checked both my solutions. They worked. And my absolute value equation here had 2 solutions. It has x equals 6 and x equals 2. What other questions do you guys have here?
So if, say like just one of the equations works out, would you just put that one equation between 2?
Yep. And you'll see that soon. All right, everyone, take a moment, jot down example 2, and think about how you'd start this problem off first. All right, we have the absolute value of 3x plus 2 plus 3 equals 4x plus 8. Are you guys listening in? What do you guys notice about this question here? What's something you see? What do you see, Nathan?
Like subtract 3.
That's a good start. I want to subtract 3 because that would help me isolate my absolute value. So I'll end up with the absolute value of 3x plus 2 equals 4x plus 5. And what do you see now that we're here? Do we have the absolute value by itself?
Yeah.
Good. Now let's make those 2 equations. So so when you're here, you have the absolute value by itself. This is where you're going to make those 2 equations. So remember, one is just drop those absolute values, which is 3x plus 2 equals 4x plus 5. So take a minute and solve for x here on your own. Alright, so you subtract 3x on both sides, subtract 5, so you should get negative 3 equals x. Now, let's make our second equation. What would our second equation look like? I'll drop my absolute value of 3x plus 2, and it should be equal to its opposite. And what would the opposite be here? What do you think, Jaden?
Negative parentheses 4x plus 5.
Good job. It's going to be negative parentheses 4x plus 5. That's how I'm going to be able to create the opposite, which means if I have a negative outside that parentheses, what do I need to do? Distribute if you have that negative outside that parentheses. So that'll become negative 4x minus 5. And now take a minute to keep solving for x here on your own. Alright, so you should find x equals a -1. So I've got my two solutions. Are we good? Are we done?
No.
No, what do I need to do with both of them?
Plug them both in.
Good job. Plug them back into check. So let's start over back when we got x equaling -3. I need to replace x with -3 everywhere I see it in that equation. So going through on the left side, I'll have 3 times -3, which gives us -9 plus 2 for -7. What's the absolute value of -7? 7. So 7 plus 3 on the left side, which I know gives us 10. Now let's figure out the right side. We'd have 4 times -3. Yeah, -12 plus 8, which I know would give us what?
-4.
Does 10 equal -4? No, those do not equal. So what do I know about -3?
It is extraneous.
It is extraneous. It does not equal. This is an extraneous solution, meaning you solved for it, you found it to be a solution, but when you plug it back in to check, it does not work. So why this happened here is if you think graphically what's going on, right? When you're solving, you can still think about your solutions graphically, right? When you solve for an x-intercept, you know, you're finding the solutions of when it equals 0. Here, think about your left side. Remember, you're always plugging, I forgot to mention that. You're always plugging it back into your original problem. So never from here, always back up to that original. If I think about my original problem, it's a absolute value. That's that V-shaped graph. What's my right side look like? It's a linear function, meaning maybe I'm a line like this. And those, a line and a V, can have a situation where they're only intersecting once, when the slope for that linear is going to be probably steeper. You're only going to find yourself intersecting one time. So think about if my line was really flat, I'd probably cross over that V shape twice. So just be cautious whenever you're solving, especially when you find yourself having variables on both sides. You'll always need to check, because you can have an extraneous solution. So while you're solving, you need to kind of know, like, hey, this actually isn't a solution, but I did solve for it and found it not to be true. And am I just going to assume this is good?
No, you gotta check those.
Right, I got to check this guy too. So let's check out. So I have 3 times -1. So plugging everywhere in for x. I'll have -3 plus 2, which I know will give us -1. The absolute value of -1 is 1. 1 plus 3 is 4. And then on the right side, we'd have -4 plus 8, which gives us what value on the right side? 4. So was this a good check? Yep. So here's my expectation on your test coming up on Tuesday. You should show that you can isolate, create those two different equations. If you find an extraneous solution, you need to communicate it. If this is your valid solution, show that it's your valid solution, right? Like circle it, box it, something like that to say, hey, that was my solution for sure. This one is not over here. What other questions do you guys have here? Do you see your question?
So is that What is the extraneous solution look like on a graph? Is it like that?
It's not going to show up. Meaning, like, I'm only going to intersect here where x equals -1. I'm not intersecting over here x is -3.
Oh, okay. I got it.
All right, why don't you guys try example 3 on your own for like 2 minutes?
Oh my god. Can you stop?
Alright, guys, so you isolate your absolute value. Alright, guys, focus back in. And you have the absolute value of 3x plus 2 equals -6. What are you guys thinking here? We have the absolute value of 3x plus 2 equals -6. What are you thinking? What do you think, Jaden?
Drop the wait, what was the question?
What does this mean? The absolute value of 3x plus 2 equals -6. What would we kind of do next solving here? What are you thinking about? Drop and keep solving? Do I need to keep solving?
No.
No, why not?
Because it's -6, so it's not moving.
Yes. There's -6 here, meaning can an absolute value ever equal a negative number?
No.
No, so I know my answer here is no solution. If you are somebody while you're solving it, drops those absolute values, made your 2 solutions, guess what? When you check your answers, you would have found both of those solutions don't work. So if you're seeing that both of those don't work, go back up to this step where you have your absolute value isolated and think, oh, was that negative? If it is, there should be no solution. Or your other option is, if you checked both your answers and both of them don't work, but this here was positive, you should check your work because that's cueing you that you probably made a mistake somewhere along the way. What's your question, Ethan?
Like, if you wrote like both of them are extraneous solutions, is that considered right? Also, technically.
You should technically write no solution.
If they're all extraneous, it's no.
Correct. So that's what I'm saying, everybody. Guys, listen back in. If you got both of them to be extraneous, look back up here and then be like, oh, yeah, that should be no solution. But if you got both of them to be extraneous and this is like a +6, then you need to check your work because you went wrong somewhere along the way. All right, our last idea is solving an inequality. All right, you guys, last idea is solving an inequality. So remember, your inequality means less than, greater than, less than or equal to, greater than or equal to. What's the difference between an inequality and an equation? Your steps while you're solving are pretty much the same, but what's something that's different about them? What do you remember?
An inequality, when you divide a negative, the inequality sign switches.
Good job. When you multiply or divide by a negative, your inequality is going to switch. And an inequality, are you going to have just x equaling like one value? No, it can be a whole range of values. So you're not going to have to like check for extraneous solutions here because it's a whole range of values. But you can plug in a value in that range to check to see if you got it right. So take a moment, jot down example 4, and then let's walk through it together. So we have the absolute value of 2 minus 1/2 x minus 1 is greater than or equal to 0. What's always our first thought with an absolute value? Yes.
Isolate.
Isolate it. So what do I need to do to isolate here? Add 1 to both sides. So we'll end up with the absolute value of 2 minus 1/2 x is greater than or equal to 1. And now I have that absolute value by itself, so we can make those 2 equations. So first up, just drop those absolute values. So I'll have 2 minus 1/2 x is greater than or equal to 1. And now let's finish solving this one together. So solving here, what are we thinking about? Next, to help get x by itself. Subtract 2 on both sides. So we'll have negative 1/2. X is greater than or equal to negative 1. And then what's your last step here to solve for x? Yeah, so you can divide by negative 1/2 or multiply by negative 2. And if you're thinking about multiplying by a
Negative, yeah.
negative or dividing by a negative, what do we have to remember to do? Switch your sign. So you'll end up with x is less than or equal to 2. So think about what that means here. At 2, I'll have a closed circle, and it's everything that's less than, which is to the left. Now let's make that second inequality. We'll have 2 minus 1/2 x. And if this was an equal sign, my 1 would change to what value? Negative 1. So, everybody focus in here. If this changed to a negative 1, what's going to happen with my inequality? It should swap around. So now I'll have less than or equal to negative 1. So when you make your second equation, you're going to make your value negative and switch your sign or flip your sign. Alright, so take a minute and finish solving this one on your own. Alright guys, so you should find x is also greater than or equal to 6. So at 6, you'd have a closed circle, and then greater than means you're shading to the right side. So notice your solution set. You don't have to draw your solution on a number line like every time, but it can be helpful to see your solutions in the sense of, are you going to have an and situation or? So what's the difference between the two? Look at your solution set. Do they cross over each other, or are they going in opposite directions? What does it look like? They're going in opposite directions. So if I'm going in opposite directions, this is going to be an or situation. And or is a little bit easier with your formatting because there's no extra steps. You can just say x is less than or equal to 2, or x is greater than or equal to 6. What questions do you guys have here before? We have just like 2 more we'll do, and then you guys will start some delta math. All right, looking at example 5, what are you guys noticing here? What do you see, Jaden?
It's multiple x values on the same side.
Yeah, and that's all within the absolute value. So you kind of notice there's nothing going on outside your absolute value. It's all within it. So let's go ahead and clean up inside that absolute value first. So I'm just take a second or two, jot down your problem, and simplify inside your absolute value first. Alright, you guys. Alright, everybody, you should end up with the absolute value of negative x minus 10 is greater than 5. So when you're here, what are we ready to do next?
Delta math.
No, we're not done with problem. Are we ready to go home? Is that our next step? I feel that. I'm ready for that step too. But the next step in the problem, what's our next step in the problem? Yeah, get rid of your absolute value. So you'd have negative x minus 10 is greater than 5. And your other situation would be negative x minus 10 is what? Less than negative 5. Good job. So you guys finished the problem out on your own for about a minute. Alright, everybody. So looking back at your solutions, you should find x is less than negative 15. And then you also have x is greater than negative 5. And what are you noticing about the solution set? Was it an and, crossing over, or opposite directions? Or just going in opposite directions. So we'll have negative x is less than negative 15 or x is greater than negative 5. Alright, you guys, you try this next problem. So check back in. You're isolating to find the absolute value of x minus 9 is less than 9. You solve to find x is less than 18. And then you also find x to be greater than 0. So what do you notice about the solution set here? Were they overlapping or going in opposite directions? They're overlapping, which means it's a what situation? And so everybody listen up real quick. So you're not given a number line like on your test, probably not on Desmos or whatever, Delta Math either. But if you want to draw one to help you see if it's an and or an or situation, that could be helpful. Because what is an and situation? You don't just write the word and in between them and call it a day like you did with or. You write it as a compound inequality, meaning like together. So it would look like 0 is less than x, which is less than 18. And that would be your final solution there. Because x is like in between 0 to 18. All of those values in between them. And if you wanted a good check, if you plugged in any value between 0 to 18, it would be a true case for that inequality. So, everybody clear on those expectations for the test?
Yes.
Yes, you write it together as a compound inequality. All right, you guys ready to start your delta math?
Yep. So was there like did you add a new delta math?
I did.